Hello everyone, welcome to JGK Masterclass. Guys, today we will see what all normal modes of vibrations are there for pyramidal molecule and its IR and Raman activity. This topic is taken from Raman spectroscopy and you can see the topic belongs to MSc chemistry students and you can find questions on CSIR net examination and GATE examination. So guys, this is my request. You can see I have taken this data from the YouTube channel that my 89% students, those who are watching my videos are non-subscribers. So it's my request to all of you that please do subscribe it. You may feel that it's of no use for you, but it will be very useful for me. So please do subscribe it so that it will motivate and encourage me to make more and more solutions for the problems which belongs to your previous year question paper. So please do subscribe it and like my videos. So now we'll see the problem of your question paper, that sketch schematically normal modes of AB3 pyramidal molecule and comment on its IR and Raman activity. So for this you have to draw normal modes of AB3 molecule, means you have to draw what all vibrations are present in AB3 molecule. So basically you just have to draw this table for this above question where you can see pyramidal molecule. So you should be aware of how to draw the structure of pyramidal molecule. Once you draw this pyramidal structure, then what all possible molecule or vibrations are there. So since it is non-linear molecule, we know 3n minus 6 is the formula, where n is the total number of atoms. It is 4 here, A, 1 and 3b plus 3. So 1 plus 3 means 4 atoms are there. So total 6 vibrations will be there. But here you can see we have 4 vibrations, means 2 vibrations are degenerated having the same energy. So you have to write down first the 4 possible vibrations. So for that you can see it is represented by nu1, nu2, nu3, nu4. This table is given by mutual as per the mutual exclusion principle. The topic I have already covered in the previous video. If you haven't seen that, I will share the link in the description box. You can go first with that video and then you can refer this particular video. So here you can see we have two symmetrical vibrations. One is symmetrical stretching, other is symmetrical bending, and two are asymmetrical vibrations. One is asymmetrical stretching and asymmetrical bending. So you can see symmetrical stretching means symmetrically you are stretching the molecule in opposite direction here, and then you have bending. 4 types of bending are there. So this is the deformation, out of plane bending. And then you have stretching, which is asymmetrical. So asymmetrically you are stretching one, you can see B atom is compressing, the other two you are stretching. So asymmetrically you are stretching the molecule. And then again you have asymmetrical out of plane bending. So this is again asymmetrically, means in irregular directions you are having the deformation of the molecule. So this pattern you have to learn. So for this particular question, if it comes, you have to draw all these 4 and then you can write the respective 4 vibrations. And then finally, if they are asking you IR and Raman activity, so for that you have to mention. For this you should be aware of all the symmetrical vibrations like symmetrical stretching or symmetrical bending are IR parallel vibrations and Raman polarized vibrations. So if you are familiar of that, you can write down I for IR and R for Raman. So you can notice here and mention, since you have written it is symmetrical, it is Raman polarized and IR parallel. Similarly, Raman polarized and IR parallel. And you can notice also that all vibrations are IR as well as Raman active. So what does the mutual exclusion principle says, that if the molecule has a center of symmetry, then some of the vibrations which are Raman active will be IR inactive, or IR active will be Raman inactive. But this pyramidal structure has no center of symmetry. Since it has no center of symmetry, some of the vibrations or maybe all vibrations are Raman and IR both active. So you can notice here all are Raman as well as IR active vibrations. So we can say the molecule does not have center of symmetry. And so for AB3 molecule, either it may be planar or it may be pyramidal. Planar is ruled out because it has a center of symmetry or planarity is there. Then here pyramidal is the option because some you can see all the vibrations are Raman and IR active here. And for asymmetrical, you should be aware that the vibrations are IR perpendicular and Raman depolarized. So this pattern, if you are familiar of, you have to just learn the two type of stretching, asymmetrical and symmetrical, and two type of banding which you can draw. So for this particular question, you have to just draw this table and learn it so that you can solve the numerical also on it. So we'll see the next problem. Let's see, explain the structure of chlorate. You can see here it is again AB3 type of molecule, chlorate, ion based on the following given data. The data is given to you here. You have to find out the structure or the shape of the molecule. So here you can notice you have Raman activity mentioned here, IR activity mentioned here, and the assignment is given nu1. So you can just see nu2, nu3, nu4 here, right? So first of all, you can notice that all the vibrations are Raman as well as IR active. What does it mean? That the molecule has no center of symmetry as per the mutual exclusion principle. So if it has no center of symmetry, you can assume the molecule has pyramidal structure. Okay, so no center of symmetry is present, therefore you can say it is pyramidal in structure. All vibrations should be Raman as well as IR active to have pyramidal structure. So you can draw the structure of chlorate, which is pyramidal, because they were asking you the structure only, and mostly they ask you to do the assignment also, which is symmetrical stretching, which is symmetrical banding or asymmetrical. So for that, as I told you, the hint that symmetrical modes of vibrations are parallel and Raman polarized. So you can see here two datas are given parallel and polarized, means this belongs to the symmetrical vibrations. So nu1 and nu2 here are symmetrical vibrations, while we have seen that asymmetrical are perpendicular and depolarized. So you have two data here which is perpendicular. Nu3 and nu4 belongs to asymmetrical vibrations. Now in that also you have to find out which belongs to stretching and which belongs to banding. Higher value will go to the stretching because it requires more energy compared to the smaller value that is belongs to banding. Similarly, 950 for perpendicular, that is asymmetrical stretching, while 434 infrared, this is for asymmetrical banding. And in that way you can say nu1 is symmetrical stretching, nu2 is symmetrical banding, nu3 is asymmetrical stretching, and nu4 is asymmetrical banding. So you can do the assignment also. So I hope you understood the type of vibrations involved in pyramidal molecule and in which condition you can say the following molecule is pyramidal in shape. All the best for your exam. See you in the next video.